Now, they really looked pretty round, and that was strange. We have found what I believe to be strong evidence that the rocks themselves are sediments that were laid down in liquid water. It's a fundamental distinction. It's like the difference between water you can draw from a well and water you can swim in.
The science team is confident that these rocks were soaking wet, and they're beginning to understand what it took to get them that way.
We're starting to get our hands around the issue of how much water is required.
It's probably extensive, but we don't yet know how extensive. And then we've seen about 15 meters thickness of layers that were deposited 1 millimeter at a time from orbit. It looks like this could be the top of a stack of maybe 500 meters of rock deposited in the same way. It could have also been a fairly deep body of water, a extensive sea the size of the Baltic Sea on the Earth, hanging around. Steve Squires also came up with the possibility that these could be ice-covered lakes.
It's like dozens of Great Lakes worth of water, probably, at a minimum, to create the deposits that we've seen, and potentially more than that. So it's a pretty watery place.
And this watery place seems to have been wet for a fairly long time.
The long time part of it is hard because you can't date stuff. I mean, the thing that gives you a gut feel that it was a long time is just that there's a lot of this stuff. When we first landed at Eagle Crater, we saw a layer of this water lane rock that was like maybe that thick. The rock was. It was only tens of centimeters, but you could sort of convince yourself if it's only that thick, it might have been kind of a brief episode. But then we drove over to this big crater, Endurance Crater, where we had the ability to go 10 meters or more down into the crater and look at the rocks deep down inside. But every single rock that we have seen, every piece of bedrock that we have seen at Meridiani has told a tale of water and almost nothing else.
But when did this watery tale begin? In other words, just how long ago was the long wet time on Mars?
That's another hard one. I mean, anything having to do with ages is difficult if you can't actually get the rocks into the laboratory. I think there's a sense that it was probably from fairly early in Martian history.
Opportunity finds a perfect place to read a sizable amount of Martian history, a little over half a mile from its landing site, in a crater named Endurance.
When I got on the mission, I really wanted to be where I could go over the hill and see what's on the other side. And one of the key aha moments was when we actually got up to Endurance Crater on Opportunity and got a chance to look inside. That was cool.
And we get to Endurance, this 150-meter diameter crater, big, deep thing, and we go through the top 10 meters of a beautifully exposed stratigraphic section and look in detail at what was happening with this ocean while these rocks were being deposited.
Endurance has been this marvelous window into the subsurface at Meridiani, showing us layered rocks that go meter after meter down into the crater. And so we've been able to do the first reading of the geologic record ever done on another planet. And that's been kind of cool.
We would make an analysis, we would grind a rock abrasion tool hole and take a measurement. That helps us get below the dust cover and any alteration that's occurred. And we systematically did that in many, many holes going all the way down. It's telling us what was changing in the chemistry of the water and how that water was changing. It might be telling us how the volume of water was changing even.
Another huge clue to water at Meridiani comes from something quite small. Actually, a whole lot of quite small somethings.
The ground is just completely covered with these little round things.
These amazing little millimeter-sized spherules that we call blueberries because they're bluer than everything else. It wouldn't really appear blue to your eye. They'd be sort of dark brown. But they're a lot bluer than everything else out there.
First PanCam pictures came down, and they looked pretty round. They really looked pretty round, and that was strange. But, you can get fooled. There are only a few pixels across in the PanCam images. We put the microscopic imager down on them, and I remember where I was standing when that first picture of those things hit the ground. And these suckers are perfect little spheres. Thousands, millions, billions of these things, we come to realize.
I think when it really nailed the door was when we measured their composition.
And we were able to get an analysis of their chemistry and mineralogy in an area where most of the field of view of the instruments was filled with these berries.
So what we did is we just drove over there and we stuck our spectrometers in there and made one measurement that was largely, not completely, but largely filled with these blueberries. And then right next to it, on the very same kind of rock, we found a spot that didn't have any. And you compare those two and you get a sense of what the blueberry component is made of.
And lo and behold, they were very rich in hematite.
That's where the hematite is, in fact, is the blueberries.
You've got these probably water-formed blueberries and this likely water-formed layering, both of which really strongly point towards the water story.